Hello again, folks, in 114. Today we're going to be covering section 12.3. Okay. Today is Wednesday, June 23rd. Nearing the end, so 12.3 is where we are. The packet looks like this. There's an overview, since we'll be covering measures of central tendencies, the more sophisticated way of saying averages. There's an overview of those types and related formulas and procedures. This I included as well because I really love this. This is from the inside cover of an old dictionary I no longer have, unfortunately. But I'm so glad I duplicated this before its demise. Whatever happened to it. It shows, it compares different Indo-European languages. And you'll see some naturally similarities because they're derived from most likely Phoenician, I would guess. What is appropriate now is especially this middle column, because you will see the names and the symbols, uppercase and lowercase, of Greek letters. In math, Greek and physics as well. Greek characters are used to represent measurements and what have you. So we can highlight a few of those for reference. Then there's another overview of types of position. You don't have to do a lot of this, but it is good to have this as a start, especially if you go into statistics afterward. This is a diagram I made for programming your calculator. Now at this point, I would definitely encourage you, make sure that you have this type of calculator. This is the type of calculator that you're allowed to use, I believe, on the praxis examination. Anyhow, so it would be good to know how to use it. When you're dealing with data, especially lots of it, you wouldn't want to suffer through the calculations by hand, 20 times. You make your calculator do the work for you. But you need to know how to program it. So this is how to set it up to give you relevant information. Let's see. This is swiped from the textbook. It's just a black and white copy because my printer's running out of ink. Of the same information, and also measures of position. And then we'll do some word problems. Okay. That aside, and I'll get rolling here. This takes 2 presses. And once again, I forgot to connect it. Okay. Still not quite awake. All right. Let me begin with this. Okay. So here again is where we are in chapter 12. Which is where basic statistics is discussed in our textbook. Alright, again, we're proceeding in this counterclockwise order. 12.1 was gathering and organizing data. Yesterday was graphs, basically. And now what we'll be talking about are types of averages and types of position. These are both from section 12.3. Okay. The alternative name or phrase for referring to these are measures of central tendency. Which sounds cool, right? But it's sufficient to just simply say types of average. All right. Measures as in something that are measured, central as in middle, and tendency as in tendency. The tendency of something to be as such. When we get into types of variation, there's an alternative phrase for this as well, types of dispersion, but variation is sufficient as well. Anyhow, we're going to be covering these two sections, parts today. Right. Now, having said that, before I do, let me again show you this neat alphabet. This is why I don't like to throw away old books. Whoever designed this person, I wish I knew who they were. Perhaps it was several people, but this used to be the inside cover of a dictionary I once had, and I'm not sure where it went. I moved at one point and I lost a lot of stuff. Anyhow, it's really neat because you could see where there is similarity between various alphabets, right, that are related, right? They have a common ancestor. Let's see. I think I may have mispronounced it before. Indo-European, all right, alphabets. These are examples of that. Aleph. This is German. I'm not sure how to pronounce A in German, but Alpha, Greek. Aleph in Hebrew. Same thing in Russian. Okay. The Greek alphabet is really where I want you to look. Because these characters are slightly different looking than the Roman alphabet. It predates it. The Roman alphabet is based upon this, most likely. Anyhow, there are certain letters that would be good to highlight. So if you happen to have a highlighter, I would just swipe it across. All right. Letters like, let's see, Mu, for example. A little bit further down here. Let me zoom in on this. There you go. That's cool. All right. This letter, Mu, the lowercase incarnation of it, looks something like a stylized U shape, but it's pronounced Mu. Anyhow, this will stand in place of something known as X bar. All right, when we get into averages, all right, depending upon whether you have a sample or a population. Another very useful one, well, here's famously pi, of course, all right, lowercase p, is sigma. All right. Sigma is this sort of spit curl, sort of Superman-esque O here, you know, flip top lid. At least in the lowercase incarnation of it. The capital sigma is more like this, to me it always looks sort of like an E, but it's not. It's an S. Alright? Anyhow, know these by sight and what their names are. Alright, and we'll get into where they would be appropriately written. Okay? For now, that should be fine, but if you're interested, you can scan through the rest of it. Delta and pi are examples that you might have seen already, of course. Pi is used to represent the irrational number, 3.14159, whatever have you. And his delta, we use often the capital delta, right? To signify that you subtract two of the same type of quantity. All right. So let me get out of here and go to types of averages to explain this diagram. Okay. All right. What is the purpose of an average or measure of central tendency? Measures of central tendency. They more or less give you a feeling that might seem a little odd in math class, right? but they do. They're meant to give you a feel for the center of data, where the middle is essentially. Right? As a matter of fact, when you're trying to distinguish one of these types of averages from another, all right, one is the literal middle. All right. Some of them are more of a procedure, and some of them are a formula, essentially. Okay? Like, for example, mid-range, you'll see it's a formula, all right? Mean, you can kind of think of it either way, but it's probably most convenient in the style of a formula. These two are definitely procedural. All right, a formula itself is procedural naturally, but it's summarized in a neat little package. Now, when would it be appropriate to use these? Oh, let me start by saying this. If you want to help remember them, my suggestion is this. When you think the mean, think the actual average. All right, I think most people intuitively do that already anyway. All right, these are all averages, but this is the one most closely associated with the word average, at least in English. All right, when you think median, right, think literal middle. Okay, when you think mode, think most. All right, there are some instances when you don't have a clear mode, or there just simply isn't one. And mid-range is more or less a cheapy, quick average, if you will. All right. Now, when would it be good to use these? You use a mean when the data are evenly spread out. Right? No huge chasms in between, gaps between one number and the next. Right? What you'll see as you do a lot of these that there are sometimes when you have a lot of numbers that are really close together, like 1, 2, 3, 4, 5, and then there's an extra number like 99, and you're like, oh, geez, that's weird, all right? Why would I even have that, all right? Sometimes you're given data sets that are like that. Anyhow, when you can tell that the data are basically evenly spread out, all right? This will become more important as we get into variation, all right? Might be appropriate to use mean among these choices, right? Median, on the other hand, is appropriate when data is skewed, right? When there is, in fact, a huge gap one way or another, right? Perhaps it's stretched, the data, by some suspiciously large or small data value. Like I said, imagine a bunch of numbers really close together, 1, 2, 3, 4, 5, and then on the end it's 99, all right? That's weird, all right? So, a more reliable average would be the median, perhaps, right, to give you an idea of what the middle ought to be, a feel for that. All right. Mode. All right. Mode is when interested in, say, popularity or preference among, say, people who are surveyed. For example, the most sold car color. Whatever is most preferred amongst people in retail would be interested in something like this. Why? Because then they will heavily stock that item, whatever it is. If I don't know if this is true or not, but perhaps Americans like red cars more than any other color car. So if you're going to sell a car, right, if you're going to manufacture a car, you'd probably make a lot of them red, and not so many in chartreuse, what have you. Mid-range, this is useful when you need just a rough estimate, as long as that's sufficient. All right, you're just getting a rough idea. Why? Because it doesn't really use all of the data, it just takes into consideration the highest and the lowest value and then averages those two. All right, now, underneath these, you'll see some procedures which are useful. They all are procedural, of course, but some are summarized more so by a formula than others. In the case of mean, the procedure is essentially to add all of the data. All right? Then you divide by what would technically be the cardinal number. Remember cardinal number from set notations. All right? It's the number of numbers. All right? The number of values. Just not to sound redundant. that is summarized by this formula that is beneath it. Don't be intimidated by this. All right, what you see down here. All right, this is the formal way of writing this concept in two parts. Remember that this line separating the top and the bottom of this sort of ratio here, right, means divide, right? N is the number of values, data values that you have, the number of numbers in a very literal way. And then there's the sigma letter that I mentioned earlier. Just like when you see a delta, think back to slopes. When you see delta x or delta y, it is an instruction to do something. It's subtracting two x's, say for example. When you see a sigma, capital sigma, in front of an x, it means add x's. So instead of delta is d in difference, sigma is s as in sum. So it'd be x1 plus x2 plus however many x's there are. Okay? And if you're dealing with data, it's usually a lot of them. So this means the very tippy top, add everything, and then the bottom is divide by how many things you have. All right, summarized. Now, notice over here there's a special symbol to distinguish the mean from the individual parts that are being combined. All right. It's called x bar. Right? And it literally is a line drawn above an X like that. Right? This is the mean of a sample, meaning not the whole thing. Right? Alternatively, what you would see is perhaps the mu symbol in place of this. So if you saw mu where x bar would be, that's the mean of an entire population. Okay, so that's just one variation on the same formula. All right. Okay. Now, this is the median column here. What's the procedure? Always, it is a good habit whenever you're given data, right, to rank it. That is, to arrange it in numerical order. It doesn't necessarily have to be least to greatest, but that would be intuitive, I think. And then you select the middle number. Now, in theory, there's two things that might happen. If there is an odd number of data, then there is one exact thing in the middle. This blue is dying. Goodbye, blue. That sounds very dry. This is not Nickelodeon, I assure you. If there's an odd number, this is much better. All right. If you have an odd number of data, cardinal number would be odd. All right. Then there's one exact number that lands in the middle. All right, and then you're done. But in theory, if there's an even number of data, what you'll have to do is to average the two. All right. That means essentially add those two things in the middle and then divide by 2. Okay. Now, what I put down here is not this formula, this procedure summarized. What I put down here is something that you might see in my lab that is very useful. It's very cool, actually. It's very useful if you have large amounts of data. All right, so I'm going to erase a little bit of the gobbledygook here because I don't want it to get distracting. And zero in on this before I move down, over, and what have you. Look here for a moment. Rank position of median. This doesn't tell you the median. Does not give median. All right? What does it do? It tells you where it is. Location. of the median. There's a simplified version of this too, which maybe you like better. If you see a sigma f, f stands for frequency, meaning that perhaps you have the same number that recurs several times. All right. So if you count everything according to how many, the total frequency of everything at once, and then you add 1 and divide by 2, that'll tell you where in the data the median would sit. All right. If you have a jumbled mess, all right, well, even if it's organized into an array and ranked numerically, arranged from least to greatest, it might still be difficult to find the middle. All right, so this will tell you how many places to count, essentially. A simplified version of this would be just n plus 1. So in place of sigma f, f stands for frequency, the sum of the frequencies, n as in the cardinal number, the number of data values, plus 1 divided by 2 would be sufficient. It accomplishes the same thing. Okay, so just beware. This is not going to give you the median. It's simply going to tell you where it's located, which is useful. All right, now look over here at mode. Mode has a similar procedure for finding it, and that's why it's a good habit, no matter what you're looking for, to start by arranging the data in numerical order, that is, rank them. Okay. In this instance, what you're going to do is select for the number that most occurs, right? That is most frequent. Now, there's 3 things that may happen. That there is one clear majority, if you will. One clear winner. One number occurs most of all. All right. Then in theory there is this possibility where you have a bimode, which is that you have 2 values occur same amount. And then there's this situation, situation 3, where there is something that would be either no mode, that is to say that there is no clear winner, for lack of a better phrase. No number repeats. Or there's more than a bimode. If a bimode situation, I'm sorry that's a little bit faint. If a bimode situation is where you have 2 values that do repeat, but they occur in the same amount, then the logic would follow that, all right, well, maybe there's a trimode, but there isn't, though. All right? Beyond 2, trimodes are not taken into consideration, all right? So don't even think of that as an actual phrase, because there isn't one. All right, but the idea of a trimode, if you had what would seem to be a trimode, we would just simply say no mode, forget it, there's no significance. All right. Of course, there could be the situation where there is no value repeating. Okay. So just beware of that. Now, again, this formula down here is not going to give you the mode, right? You just it's the easiest thing to look for, really, just to put things in numerical order and then see which one occurs the most often. But it's related, so I put it underneath here for reference. In my lab, you might get a question related to this, so just explain this for a moment. This is called W with a bar above it, a weighted mean. And it's basically taking into consideration that data that most frequently occurs. Data of higher frequency that is recurring, exerts more influence on the average. That's intuitive, right? Right, so what this means is you're going to sum that's the sigma there again. You're going to sum the data as you always would, right? But this is this parentheses here is that what you will do for each data value is you will write the data value, that is the x value, and you will multiply by its frequency. So if you had the same number occur 3 times, it would be that value times 3, right? Plus the next data value times its frequency, plus the next data value times its frequency, which may just be 1, right? And then you divide by the sum of the frequencies. It really accomplishes an average just as you normally would, but it's another way of thinking about it, right? Right? It's meant to illustrate this idea that data of a higher frequency would naturally exert more weight, more influence on the overall average. Okay? Let me get this out of the way. Why did I put this underneath the mode? Because the mode is about something that recurs, so something that has a frequency. Right? Again, this is not going to give you the mode, but it is related to the mode. The last thing is this. The mid-range is to simply add the highest and the lowest values. You must put them in order to determine that, and then divide by 2. This is a very quick way to calculate a sort of average by just taking the extrema into consideration. If you again have data that is basically evenly spread, then this is a quick way to get the average. You know? It wouldn't be, in theory, as accurate. It's not going to match this exactly, right? But it'll be very close to the regular mean. Right? But it's called mid-range. Low plus high, divide by 2. Okay, so these are the different types of averages that we have to work with, and you may have problems that they ask you to find all 4 and then compare the best 3. Right? What is the point again? Again, it gives you a feeling. Believe it or not, it's hard to think of math as something that is, humanly has a feeling attached to it, but that's the beauty of statistics, right? Statistics makes math more human, right? So it's very agreeable. Let's do some examples now. So I'm going to go down here and turn on the word problems, and we'll go through these. All right. Let me see if I need to have it so dark in here. Now in the case of this first problem, it says determine the mean age of a group of firefighters and the ages of if the ages of the individuals are 30, 21, 51, 37, and 51. Notice that they are intentionally given to you out of whack. So a good habit is to automatically rank something. Why? Because normally it isn't just asking for the mean, it's probably asking for the median and mode as well. So I would get in that habit, right? When you're ranking something, right, do what you do when you have an array, which is cross out as you're proceeding to make it easier as you proceed. All right, so what appears to be the lowest number in here is 21. That would go first. All right, and then the next lowest would be 30. And then the next lowest would be 37, or the next highest, I should say. And then you have a 51 and a second 51. All right. If they're asking for the mean, right, then you know the procedure is that you would have to add these. All right. And in that case, what you should get is 190. And then you would divide by how many there are. Sorry, I dropped my markers all the time. There is 1, 2, 3, 4, 5 pieces of data, so you would divide by 5. Okay. 5 goes into 19 roughly 3 times, with 4 left over, and 5 goes into 40 exactly 8 times, which means that the average, the mean average, is 38 years old. All right. Save that, because the information is then recycled to calculate a median, right? Because now we've already done the work of putting things in numerical order, ranking them, all right? When we calculate the median, it's not going to be a difficulty at all, right? We just have to stare at what the middle is. Right? If there is an odd number of data, right, the cardinal number is equal to 5, so therefore this is odd. That means that there's one exact middle, which means that the average in this case would be 37. Right? This is median. Now, just to sneak it in here, let us say that you had the data. You don't have to do this because they didn't ask you for it. But I want to show you something. In my lab, a lot of times they give you a table that looks like this. Well, they'll have the data, as I've written it horizontally, more or less presented vertically. So I'm going to write 21, 30, 37, and 51 just written one time, all right? Because these are the data values that are distinct, and then there'll be a column adjacent to it labeled F as in frequency, and you'll see figures like this. There's 121, 130, 137, and 2 51s, all right? In a case of just 5 numbers, right, it isn't difficult at all, right, to go, that's the middle, right? But if you had a much larger quantity of values, it's a little bit trickier and it might be easy to make a mistake. So if you use this position formula, either this incarnation of it, the sum of the frequencies plus 1 divided by 2, or this one, because they accomplish the exact same thing. This will identify the location of the middle, right, the median, right? The frequency would be, how many is the frequency here? 2, 3, 4, 5. That's 5. So you could put the 5 here in the formula. Sorry, that's a bit faint. Or you could put the 5 here, because the cardinal number and the sum of the frequencies should be the same thing. Add the tops, divide by 2, right? 5 plus 1 is 6 in either case. Divide by 2, divide by 2, and what's half of 6? Third. It's 3 as a numeral, right? But again, it's the position of the median. So starting from the far left and counting 3 of them, 1, 2, 3, that's the third one. Right? Again, it's super easy when you have only 5 data values to work with. But beware of that. When you have something a little bit more ugly, you can always rely on this to tell you where the median ought to be. Okay? So let's look down at these 2 examples of median further. And I'll scoot this up here. Number 3 is determine the median of, instead, an even number of pieces of data and an odd number of data. Now again, you have to put these things in numerical order, so do that first as a procedure. Scan from left to right. All right, what's the smallest value? It is to be 11. And there's 2 of them. And the next number is 12. And then, 9 would be the smallest in the total. 9, 1, 11, 11, 12. And then, standing in the way, that's the problem. 14, and 2 16s, and a 17. Okay, now, what is the cardinal number here? 1, 2, 3, 4, 5, 6, 7, 8. This is 8 data values, so it's even. That means that you have to find the 2 in the middle and average them. So, again, if you have a limited bunch of data here, all right, it isn't too difficult to go, well, these are the 2 things in the middle. All right, there are 3 data values before, and there are 3 data values after. All right. And you would add, you take an average of these 2, would be 12 plus 14, which is 26, and you divide by 2, and you would get 13. Now, one thing you'll notice is, you do these a lot, is that, well, that would have been the figure, 13, that is exactly in between them anyway, all right? So if you could figure out, guess in your mind, you know, what exactly the middle would be between these 2 values, whatever they are, then that's indeed what the middle is. Halfway between 12 and 14 is indeed 13. Now again, humanly, if you use the position formula, you'll see what you get. N plus 1 divided by 2. All right, how many data values are there? There's 8 of them. So if I put 8 here, 8 plus 1 would be 9, and 9 divided by 2 would be 4.5. So this is between 4 and 5 if it's 4.5, right? 1, 2, 3, 4 is 12, 5 is 14, and halfway in between, and again, would be that value of 13. So you would know to look for the 4th and the 5th. Okay, here's another one. This is already put in order. Let's count them. 1, 2, 3, 4, 5, 6. All right. Especially with such a finite amount, we're going to have 2 in the middle. It's easy to identify, and they are identical, though. They're identical. So even if you decided to add these, which is cool to check, you'd get 16 divided by 2. What are you guaranteed to get again? 8. Right. Again, you tried the position formula. The number of data values would be 6 in this case, right? 1, 2, 3, 4, 5, 6. Plus 1 is 7. Half of 7 is 3.5, which means between 3 and 4. That is 3rd and 4th. So 1, 2, 3, 8 here is 3, this other 8 is 4, this would be the in between them, and it would have to be the same value because there's no difference between 8 and 8. Okay. Now, this question here is about the firefighters again. So without scanning up, let me give you the data set that was related to this. From earlier. 21, 30, 37, 51, and 51. And what we did calculate was both the mean and the median of these dudes here. All right, the median, the mean was 38, and the median was 37 from earlier. Okay, now the mode would be the number that occurs the most often. So to put this adjacent, the mode would be 51. Once you have established basically more than one type of average, a mean in this case, a median, and a mode, you have some choices to choose from, right? This isn't something you're required to do, but I feel that if you had to choose the best average, all right, if you're asked best average, rank these. You need realistically 3 of them, all right, and you have the main 3. So 37, 38, and 51 would be then in order, right? Which is the middle of the middles. Well, 37 is less than 38, and 38 is less than 51. My logic is 38 is in fact the best average. All right, 51 is a dud. 37 is pretty reasonable too, but of those 3 things, that's the actual middle of the middles, if you will. Next is determine the mid-range of the same group of firefighters. All right, now it's mid-range is that formula of the low value plus the high value divided by 2. Right. So the low value in this case is 21, and the high value is 51. And in that instance, you get 72. And if you divide 72 in half, you get something pretty reasonable, 36, right? That's not too far off from these other 2 of the main 3, mean, median, and mode. Right. So it isn't unreasonable. If you were going to compare between these 3, (36, 37, and 38), since those are the things that are reasonably close to one another. And in that regard, the median would be the best average. It would be the middle of the middles. If you're going to ignore mode. All right, now, measures of central tendency, again, is the fancy way of saying types of average. Right? The salaries of 8 selected social workers rounded to the nearest $1,000 are $40,000, $25,000, $28,000, $35,000, $42,000, $60,000, and $60,000, and $73,000. That's a beautiful thing about data too. When things are in the same range as these are of thousands, a magnitude of the number times 1,000, then you really just need to include those first 2 digits. You don't have to worry about the extra 3. All right. For this set of data, determine the mean, the median, the mode, and the mid-range. Then list the measures of central tendency from lowest two highest to compare them, similar to what I had alluded to a moment ago. All right, so let's do that. All right, let's rank them. Let me see if I can scoop this up just a little bit more. That's all okay. I'll put it up here. Of these, which is the low figure, 25,000, which is shameful because, you know, that's such an important job, social worker, you know. You should think that someone who does such an important job would make more money. Life is, society needs to change, quite frankly. Anyhow, 25,000, 28,000 would be the next one, it seems. Then 35 and 40, 42, the 60s, and 73 ranked. All right. Now, again, if you're going to calculate the mean, I'll put this here. Mean, median, mode, and mid-range, MR, I'm just going to call it. We can compare them once we have them. All right. Let's do the easy ones first. All right. The median would be the number right in the middle. Let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8. There's 2 in the middle. So that would be these two that we would have to stare at, right? Because there's 3 before and there's 3 after, all right? If this is 40 on one extreme and 42 on the other, what would be exactly in between 40 and 42? 41, right? Without even doing the calculation. That would be the median, right? Let's do the second, well, even this is arguably easier. What is the number that occurs the most often? 60,000. So, just to make it evident that we are talking about money, I'm going to put the dollar sign in here and K after it for 1,000. 60K. All right. The mid-range is the next easiest. It's just adding 25 and 37. That'd probably be 73. I'm getting dyslexic now. 73 plus 25. 8 is 98. Divide by 2. 2 goes into 9 roughly 4 times with 1 left over, and 2 goes into 18 exactly 49. So this is 49K. Now's a good opportunity. I'm going to take this down for a moment and show you how to use your calculator, because we're getting into the territory of having a lot of figures to work with. So look at this for a moment. All right, this is setting up your calculator to give you some basic information. I don't want to erase what I wrote there, so humor me. What you're going to do is you're going to set up one variable statistics, which is pressing this sequence of buttons on your calculator, second and then data. All right. If you need to clear your calculator first, assuming that somebody has been messing with it, then do this first. Second data, and then scroll over to where it says clear data to end and press enter. I'll do that now. Here's your calculator, and I'll turn it on first, of course. Here's the button that is designated second, and here's the button designated data. Notice behind it is stat for statistics, right? The lighter color blue is referring to the operations behind in paint here, that is lighter blue. I'm going to scroll over to let me go over to the end. You'll see it says clear data, and that will erase any junk that's been in there already. Okay, now I have to set the calculator to deal with one variable statistics. That's this. I'm sorry for the mess in the way. Set up one variable statistics, right? There's a second option you may have noticed already. Two variable statistics. That's when we get to the latter half of chapter 12. For right now, we're just dealing with one variable, just x. So we're going to choose that. And now what we should be able to do, and just as to verify down here, is we're going to enter new data. If you want to enter new data, all right, you'll press the data button, and then you'll see x1 subscript and a blank space, x2 if you scroll down and a blank space, and so forth. That's going to be entering the salaries, all right, up here. All right, now you could type the actual figure, 25,000, 28,000, and so forth, or just remember to multiply by 1,000 later. It's up to you. But here, if you press data now, you'll see that there's a void here where you could enter the value. So this figure that you see here, 25, I'm going to type. Then I'm going to scroll down and type 28, enter. Then 35, 40, 42, 60s, and the 73. So it's better to look at it. 25, scroll down, skip over what says frequency, because it's not necessary unless you want to use that. In a more difficult problem, it might be conducive, but it's not really helpful right now. $60 would have a frequency of 2 without having to type it twice. But that's not too arduous. So, alright, now that these have been entered, let me just show you what it looks like. If you see I've entered 25 for $25,000, the frequency is 1, you don't have to mess with that at all. The only time in this case that you might want to use frequency is in the case of the 60s. It would just spare you from having to type 60 twice. Right? It's more beneficial when you have a lot of data that repeats. Here's 28,000, 35, 40, 42. The 60s, I could have put 2 for the frequency. I didn't, I typed it twice. And then 73. Okay. Now that the data is in the calculator, here's the next part here. To view basic calculations, if you press stat var, which is the button that is adjacent here, it'll tell you this information, at least. N is the number of data, the cardinal number. X bar is the mean. All right. These other things that you see, S and then a lowercase sigma, this is standard deviation, which you don't have to worry about right now. All right. It's really just the value here, X bar, that we're after. So I don't know why it says negative, that's weird. I pressed something while I was holding it, so 73, ding dong. Okay. So, stat, and here you have it. We already knew that there was 8 values. We want X bar. Scroll over, that's the value. It says 42.375, right? This is times 1,000 though, so $42,375. Just be careful of that. The magnitude is off, you know, because I didn't put the extra zeros in. Okay. Later on we'll get into second variable statistics, but it's not important right now. Here we go. All right. This value is 45,000. Sorry, I'm reading it backwards. 45,000, 375. Actually written out. Dollars. Okay, so the last thing is list the measures of central tendency from lowest to highest. What is the smallest figure? The median. So I'm going to put this here. The median would be smaller than the mean, which would be smaller than the mode. Pardon me, the mid-range would be the next one. And the mode. Okay, so if this is, to make it easy to see, 41,000, and the mean is 45,375, and mid-range is 49,000, and the mode is 60,000. You can see that there are three values that are relatively close. These three, I would say, are the best three. All right. And if I were going, they didn't ask you to do this, but if I were going to choose, I always choose among the best three. What's the middle of the middles? The actual mean in this case. All right. All right. Now, before we get into position, let me show you that overview that I have prepared. Okay? And then we'll come back to these remaining questions, 7 and 8. So here's another diagram. To summarize, all right. Just like basically the purpose of the mean is to give you a feel for the center of data, position is meant to describe where the value is in the data set. All right, and you have basically two types that you look for. All right. The two types that are discussed, describing where a value is inside of the whole, and just bear in mind, this is important. All right, the data must be in numerical order. Always put your data in numerical order. All right. There's percentile rank, and then there's quartiles. All right. You've probably heard about this when you took, say, some kind of standardized test in, at least in the United States. Somewhere in K through 12, you likely had a test, and they said, I don't know, 79th percentile, what have you. All right. The alternative names for percentiles is percent rank, or such and such nth percentile, right? The use of this, right? Percent rank indicates the percent of the data below a point, the point where you are, okay? So 79th percentile means that there's about, or in this case I use 75 as the example here. 75th percentile means you outperformed 75% of all participants on an exam. That doesn't mean that you got 75% of the answers correct, right? Which is what people often conflate. Nor that you are 75th in the list, unless you had maybe, 100 exactly, 100 people, right? But it's not necessarily, what it means is that 75% are below you. Right? 75% of the data, which may be a person, all right, are below you. All right. this 75th in the actual list is not necessarily, okay? It really depends on how many people are there. There's a formula, right, as there often is, right? It's this, right? If you wanted to calculate percent rank, I'm sorry that this is so long. I just wrote it underneath it, right? The number of data below a point divided by, remember this line is divided by, the total number of data values, that is the cardinal number, right? And then this will naturally make a decimal when you divide the top by the bottom, right? And then in order to translate it into a percentage, you multiply by 100. Okay? Now on this side, the quartiles, let me go up again. There are 3 points that you would need to determine, right, to separate data into quartiles. Right, here's a simple number line. Let's see. This is the basis of what is referred to as a box and whisker plot. The data that would fit from, say, here to here would be the first quartile, and from here to here, second quartile, from here to here, third. Okay? In theory, just to compare it back to this, /25th percentile would exist from here to here, right? 50th percentile would exist from here and here, and 75th would be from here to here, right, in your data. Right, what these ends here at the extreme of would be, this is the lowest value, and this would be the highest value. Whatever's given unique to the problem. Now, you're not really responsible for this, but if you take statistics, you might be tasked with looking for or defining what are outliers, which is essentially suspiciously large or small data that's not really reliable, right? It's so far outside the scope of what is considered good data, right? Outliers, as to be negligible. Anyhow, there's something called the interquartile range as part of that calculation, right? The interquartile range would be, once you've determined what the number is that sits here, unique to the problem, and what the number is that sits here, quartile 1, quartile 3 point. If you subtract them, you get the interquartile range. I want to say that if you calculate this and then multiply by 1.5, right? Any data value that is beyond that product, all right, or well below that product, on the other side, would be considered an outlier officially. Anyhow, what you are responsible for is basically calculating these 3 points. The one that is right smack in the middle here, what is dubbed Q subscript 2, this is the median, the actual median of the data. Quartile 1 is the median of the lower half. Quartile 3 is the median of the upper half. Right? So the position formula might be useful to you in an instance of this. Okay. So take a look at this as a procedure. you're going to do as you always do. You're going to rank the data from least to greatest. Right? That's just good habit. All right, and you would need to do it in this case. Then you're going to calculate the median. All right, the median, as I mentioned, is Q2, Q subscript 2. Then you're going to calculate the median of the data that is less than that, the lower half. The lower half, and that is going to be designated Q1. And then you're going to calculate the median of the data greater than Q2. This is the upper half, and designate that Q3. Again, if you were looking for outliers, which you're not responsible for, if you have a figure that is above Q3 by 1.5 times the interquartile range, or below quartile 1, that is minus 1.5 times the interquartile range, then officially, sorry, I'm spitting now, getting all foaming at the mouth. If you have something that is that far above or below Q1 or Q3, that's product of 1.5 times the difference interquartile range, then you're certified as being a dud, essentially. All right, an outlier. All right, some suspiciously large or small piece of data. In terms of science, if you have some measurement that is that wacky like that, then you might, go back to the measuring instrument and go, try to figure out what happened. Maybe it broke while it was recording. All right, so we're going to basically follow this procedure to calculate Q1, Q2, and Q3, but in the order of Q2 and then either of those. All right, and if they ask us for percentile rank, we will follow this formula. All right, so back here, take a look at these last two. Kara took an English achievement test to obtain college credit by exam for freshman English. The score was 81st percentile. Please explain what that means. All right. That means essentially Kara outperformed about 81% of all test takers. Right. Another way of saying that is that Kara's score, in theory, whatever she got correct, right, would be above 81% of the other people. Without actually knowing what the score is, right? Without specifying what her score is, right? Hers would be above 81% of the total data. If the data are student scores, then that's what that is, right? The other data. In theory, if you change the perspective a little bit, on the flip side, I'm not trying to be disparaging of this Kara person at all, but if 81% are below you, how much is above you, right? The bounds, right? This implies 19% above Kara. Okay? So start. What does it mean? It means Kara outperformed about 81% of all test takers. You could say that her score is 81% of all other student scores, right? Her data value is above 81% of the other data values, right? Or you could, if you flip the perspective, this implies that there's 19% above her, right, of the test takers. Okay. Let's look at this, looking for quartiles now. Here you have a data array, right? It's just not in an actual frame, right? Electronics world is concerned about the high turnover of its sales staff. I'm sorry, I should be laughing. High turnover is a bunch of people leaving, right? Quitting their job. Okay? A survey was done to determine how long in months the sales staff had been in their current position. The responses of 27 sales staff follow, right? Determine quartile 1, 2, and 3 subscripts. Now notice that this is a jumbled mess, all right? So what you would have to do is yourself translate this, sort of a preliminary step. Translate into an array in numerical order first. All right. Let me borrow some information from this first. Right. They mention, right, these are months, all right, that the sales staff have been in their current position. So 25 months, 3 months, 7 months, 15 months, and so forth. But there's 27 people that they got here. So I'm going to borrow the columns here, at least, as I can translate this into an array just below it. All right, so you'll see what I'm doing in a moment. Is that, at least I have a ledge. Now there's 3 rows as well, so what I'll do is I'll make 3 of my own, and I'll just cut it off here. Let's see, is it parallel? It's as close as it's going to get. I have a little bit of a shadow, unfortunately, it's screwing me up. So now I have the same number of boxes, basically. And I'm going to get rid of the excess. Okay. And I'm going to take this information here and put them in the appropriate numerical order instead, because I really do need to do that. Okay. If you scan from left to right each of these given rows, I will record them in here in the appropriate order. It seems that the lowest figure is 2 months. So I'm going to put a 2 here and then cross it out. And then there's a 3 here, 3 months. And let's see, proceeding along, looks like 5 months is next, and 6 months, and then 7, and then 8, and then 9, and then 10, and 11, 12. Beware that they may repeat, at some point. Do you see another 12? No, there's a 21. There appears to be no 13, but there's a 14. And the 15, coincidentally under the 5 here. And the 16. And the 17. And 18. And 19. It's kind of puts you in a Zen sort of state of mind, right? To watch somebody else doing it may be a little dull, right? But when you do it yourself, it's very meditative, So don't be dissuaded. Let's see, 19. Then looks like 21, and there's 2 21s. That one and that one. I skipped a 20. Ding dong. 20, and then here's the extra 21, sorry. You have to be careful. Better to do this in pencil if you can help it. Alright, then 24. Yep, 23 is first. And 24. 25. 27. 7's all lined up, that's cool. 31. 36. 39. And 42 months. Okay. It's as tedious as it is. It's not really difficult. Alright, it's just time consuming, it's tedious. But it's imperative that you do organize this appropriately. Alright. So if we were going to establish basically a number line, and I'll just use this up here. First things first. Alright, we need to establish Q1, the actual genuine median. I'm going to call that Q2. Alright? And that will be right smack in the middle, Q2. Okay? You could, if you wanted to, since you know that there are 27, realize that there's an even amount of data. Alright? So you could just try to figure out how many they should occur before and how many they should occur after. But there's an actual formula, so why not take advantage of that? Remember, the position of the median is the number of data plus 1 divided by 2. Alright? Or the frequencies is the same difference, the sum of the frequencies. Alright? There's 27. Alright, of these, it's a 3 by 9 row. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 27 plus 1 would be 28 naturally, and half of that would be 14th. So the 14th value in numerical order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14. That's the median right there. So that would be 17. All right, and now you could do either Q2 or Q3 if you'd like. All right. I'm just going to go get Q1. Q1, remember, is the median of the lower half. You could, again, if you want to, count how many things and just determine how many there would be in the middle. All right, we'll use this formula again. Position of Q1 would be number of data values divided by 2. Now, it's lesser than these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data values. So what is 13 plus 1? Right? 14. What's half of 14? The 7th data value. All right, so counting from here, from 2, 1, 2, 3, 4, 5, 6, 7. Don't go to sleep yet. Come on. That's the 7th data value. That would be Q1. That's 9. I don't like the way that looks. Okay. And now you're going to get Q3, the median of the upper half. Alright, which is essentially the same process. Alright, it would be 14 data values above, and it would be the 7th one above. So, starting from 18, 1, 2, 3, 4, 5, 6, 7 is here. 24. Q3, 24. Alright. Again, this is the basis of something called a box and Whisker plot. Which a lot of times is, if you complete it, it would be a rectangle like this, and the edges of the rectangle would be Q1 and Q3. Right? The low number would be 2, and the high number would be 42. Okay, but the median, genuine median is 17. The median of the lower half, Q1, is 9. And the median of the upper half, Q3, is 24. Okay? This is a very good usage of this formula. Rather than doing it brute force, which works, all right? You could just figure out what would be the number that sits in the middle, even if it was even. All right? But take advantage. All right? Your textbook does not include this, but it is something that is mentioned in my lab if you get the opportunity to look at that. And you should. Okay? And I believe that is it for today. Okay, so let me turn this off. And just remind you, for homework, do section 12.3 in my lab. And you're good to go. Put that in there. All right. Thank you guys. I'll see you again tomorrow. Be careful out there.